Industrious iOS developers, it's Prof G, and in this lesson we're going to learn about LazyStacks and LazyGrids. You'll learn that rather than lackadaisical, they are actually quite powerful. We'll also learn about extracting subviews, working with ScrollViews, using ranges for a ForEach statement, and a whole bunch of Xcode tips, tricks, and techniques. So let the big learning commence! Now, even if you haven't built the Dungeon Dice app, we're going to build a separate app to demonstrate LazyStacks and LazyGrids. But at the end of this, we'll also be able to apply what we've learned, issuing a challenge to modify the Dungeon Dice app. And here's what we're heading toward. In our prior lesson, we showed how we could use ForEach in SwiftUI to iterate through our enum and create a button for every enum case, even though we have only one block of button code in here. And while this is cool, we'd like to have our buttons listed left to right, top to bottom, across multiple rows and columns, fitting as many rows and columns that fit inside the device that we're running our app on. Now we'll learn to do all of that, but before we get there, let's learn about LazyStacks and LazyGrids, and we'll do this by building a small demonstration app together, and while we're building this app, we'll learn a bunch of new concepts that'll be useful throughout your career as a SwiftUI developer. So let's create our new demonstration app, head to the File menu, select New, Project. This is a standard iOS app with SwiftUI selected, and I'm going to name my app Lazy Demos, and I'll save this to the desktop, adjust my screen, and if you want your app results to look identical to mine, you'll want to select iPhone 14 Pro from under the scheme so that our devices have the same dimensions. Now inside the VStack, let's create some rectangles to display, and we'll set this up so that we have a fixed sized rectangle, but we'll also add a background color that'll expand to the size of every row, column, or grid item cell, and this will give us a better view of how real objects are likely to display inside of stacks and grids. So first, let's delete the image and the text that are inside the VStack. Then to create a color that's going to be behind each element, I'm going to create a ZStack, which for fans of the classic 70s children's show Land of the Lost is not to be confused with a SLEEStack. Totally different things. And inside, I'll add capital C color, passing in .red in between parens. Then under this, which in a ZStack really means on top of this, I'll create a rectangle, capital R, open and close parens. I'll modify this with a .fill. Then I'll pass in .cyan, which is a lighter blue. Although, of course, feel free to use whatever colors you think will give a good contrast and be easy to see. Then below this, I'll add a .frame modifier. And just to be sure all of you know this tip, watch what I'm doing here. I'm typing in FRA, the frame options show up, and if I were to press return to select this, I would get the frame modifier in parentheses, but none of the argument labels inside. But to get an argument label selected as well, I just enter characters to the right after FRA that contain characters only in the argument labels. So if I add W, the width gets highlighted too, and if I add H, the height argument label is also highlighted. So by typing FRAWH, I select not only the frame option, but I also highlight the argument labels for width and height. If I press return, frame with the width and height labels are both entered for me. Yet another useful pro tip to make your Xcode code completion more efficient. Now I'll pass in 100 for both the width and height sizes. Now notice the color behind the rectangle takes up the whole VStack. This is going to change when we start to work with multiple items in stacks and grids. And now another thing we're ready to learn is that we can enclose view code in a separate view, then refer to this new separate view inside of our other views. Now this is really good for reusability if you're creating several views, but for us it's also going to help make our code more compact and readable, so we can replace the 6 lines of code for the ZStack with a 1-line reference in the main content view, since from this point forward we really want to focus on the main content view, not necessarily what's inside the ZStack. So let me show you how we do this. I'm going to command click on ZStack to bring up the quick actions menu. Then I'm going to select extract subview. And look at what happens. Inside the VStack is the word extracted subview in parens, upper camel case. This is now the name of a new extracted subview. But we'll change that name. If we scroll to the bottom of the file, we can see an entirely new struct. And note that this starts flush left, so it's not part of any existing struct. It's a separate struct of type view, so it's a separate view. It includes its own body property, this body variable computed property, which is required by all views. And inside this is the ZStack with all of our code. Cool. Now I'm going to highlight, cut this out, and paste it above the preview provider code. We haven't done much with preview provider code in here. This code here simply sets up the preview canvas to show the content view. We will see in future lessons that there are times when we want to modify this to update how things show in the preview canvas. But to be clear, this code here never impacts the actual app that's installed on a device. And since it's separate from the, in quotes, real device executing code, if I have preview code, I like to make sure that this is the last thing that shows up in any file. Now we see the new view that I just moved is called extracted view, upper camel case, not a very distinctive name, so let's change this this, I'm going to right-click on the extracted view name up top, select Refactor, then Rename. Xcode folds up the code to show me all the occurrences of the value that I just highlighted, extracted view. And if I type over this, any changes occur in both places. So I'm going to change the name of this view to red and cyan view, upper camel case. That's the standard for creating types like this struct, which is a view. Press return, and my updates are accepted. So to be clear, I'm executing the content view. Whenever the red and cyan view line with parens is encountered, this jumps down to this struct here and runs this code to create a new view. See how the content view and the red cyan view have similar structures up top? The struct lines are the same except for the name, and the body property declarations are identical. It's just that this one, the content view up here, evokes the creation of this one, the red and cyan view down here. Cool. Our code is now neater. Now let's create a whole bunch of them. You can put a range and a for each, so let's do this as an easy way to create 1,000 things. On a new line below VStack, enter and select for each. You just need the data and content here. For data, we'll enter a range and be sure to do this as a half open range. 0, 2 dots, less than symbol, 1,000. That'll go through for each 1,000 times. Then tab to content, press return for trailing closure format. We need a value for the constant that we're going to pass in between the for each's parens, and initially we're not going to use this, but we eventually will, so I'll just enter it right now and I'll call it I. Cut out the red and cyan line below and paste it between the parens, and whoa, we just created 1,000 views. These have a fixed height of 100 because of the rectangle's frame, but the width expands to fill the available space. Now let's learn a little bit about our friend ForEach. I have no idea why, but as of this video recording, and for the past several years, you cannot use closed ranges with the SwiftUI ForEach statement. Try this. Change this half-open range to 0.1,000. We get an error. Cannot convert closed range to range. Totally weird. SwiftUI only accepts half-open ranges in a for each. It doesn't seem like this would be tough to do programmatically, and I very much think closed ranges are easier to read than half-open ranges. Let's go back to the half-open range. Remember, we'll go up to, but we'll never reach the number 1,000, but we're starting at 0, so we'll get 1,000 passes through this loop. And you might remember that I warned you way back when we covered ranges that SwiftUI actually requires half-open ranges for some key statements, and now here's your example. Now another thing, we can't scroll to see all of these rectangles. Well, if we want to scroll through them, we wrap the for each statement in a scroll view. Now before we add the scroll view, notice that the VStack ignores the safe area. We're drawing views right through the top and bottom of the device screen. Now enter scroll view above VStack, upper camel case for scroll view. Code completion says this is a scrollable view. Sure enough it is. Select this with a return, add open and close curlies, cut out the VStack, paste it inside, and notice the VStack now starts below the safe area at the top. It ignores the safe area at the bottom, and if you click your mouse and scroll through in the preview, you can see we scroll through the safe area at the top. Now we do have padding on the VStack. If we move that padding to the scroll view, so that would be down one line, interesting. So it now preserves the safe areas. If you want to, you can also add a dot ignores safe area after padding, and you can see that now you can scroll through the top and bottom again. Cool. I'm going to keep the padding where it is, but I'm going to remove ignore safe area. Now, in order to contrast the LazyVGrid, which is loading views only when we first need to show them on screen, versus the non-lazy loading, which is what we have here, where we create all 1,000 views at once, let's add a print statement so that we print out the value for I each time we go through the for each loop. Now, in SwiftUI, you can't just put a print statement in like this. In between the for each loop, why don't we say print, and in quotes I'll say, dang, space, string interp I. We get this error that says type, parentheses, can't conform to view. Now, we could use a dot on appear modifier just below the red and cyan view and put a print statement in between the curlies, but here's a very sneaky trick that you can use with one line of code. So let's change the print statement to let underscore equals before the print statement. Now the let statement creates a constant, which is allowed in a view, but the underscore ignores that constant, so we don't use the constant, but we do execute the function to the right of the equal sign, which is the print statement. Now we don't see prints in the live preview in SwiftUI, but we can build and run and look at the console, and look at the console! Dang, that's a lot of dangs. Dang times 1,000 to be exact. Now in this example, we calculated all 1,000 views at once and loaded them all at once. We could have had hundreds of thousands of views, and that would have slowed down your device, and if you were accessing the internet to get data for each row, that would be really slow, and you wouldn't want to do that. So it would be much more efficient if we only created a view when we needed to display it on screen, and that's what lazy loading does. The LazyVStack only creates views when they're needed, leading to a faster app and only using memory when it's needed. Now, one thing worth pointing out, we actually didn't need the VStack in here. Once we have a scroll view, it acts as a VStack, so we can comment out the VStack and its closing curlies, run it in the simulator, we still get 1,000 dangs, things work, we didn't need the VStack. But when we use the LazyVStack, we will need to add this inside of the scroll view. So we can uncomment the VStack, and then let's change VStack, replacing it with LazyVStack, upper camel case. And note, code completion says, creates views only as needed. Cool, just what we just said. Press return to accept this. Build and run in the simulator, and look at this. We get 7 rectangles on an iPhone 14 Pro screen, and check out that console. Now, we've got a little bit of strange behavior here. For some reason, we see 2 print statements for every 1 rectangle. I'm not sure if this is a bug or some sort of behavior in SwiftUI that I don't completely understand. If you know why, you can comment below. If I find out for sure, I'll put something down in the comments. The print does look like a bit of a quirk, because if we were to run this in onAppear, we would only get 7 print statements down below, and we didn't have any of these duplicates when we use the non-LazyVStack, but in either case we see 7 rectangles printing on screen, and the value for the I that we print doesn't go beyond 6, so we can see indeed that we are lazy loading here. Now also watch what happens when we scroll. We get a new set of print lines for each rec that we've created. That's the lazy part. LazyStcks will only create views inside of them when they need to be displayed inside the app. Memory saved, faster app. And if there's a LazyVStack, do you think there's a LazyHStack? Yes, there is. Why don't we change LazyV to LazyH? And in the scroll view, we also have to add parentheses right after scroll view. It's vertical by default, but if we say period horizontal inside, then check this out in the preview. Look at this, we can scroll horizontally. Nice. Now let's undo this to get back to the LazyVStack, removing the horizontal scroll view scrolling. And now let's get a quick look at LazyVGrids and LazyHGrids. And once we have this down, we'll be able to apply some of that learning in our app. Now let's delete LazyVStack and its closing curly, and instead, just above ForEach, let's enter LazyVGrid, and look, it wants columns and content. Choose that, then tab away from columns for now. This next part, the content, is a closure. So with that selected, press return to get the trailing closure format, then cut out the ForEach and paste it in between the LazyVGrids curlies. Now shift tab back to columns. This wants what looks like an array of grid items. See the square brackets? Let's try to create one and see if code completion will tell us more about what it wants. So I'll put in the square brackets, then between those square brackets, type grid item. Now one option says row or column on a LazyGrid. The one below this, let's select this one. It says creates a grid item with a specified size, spacing, and alignment. Let's select this one, press return. Now a grid item specifies what a given cell in a grid will look like. So the default, even though we don't have anything between the parentheses, is a type called .flexible. We have only one column, so this pretty much looks like a stack, not a grid. Not an improvement. But we can go back in between the parens after grid item here, press a period to see the different type of grid items we can create. And we can see in SwiftUI there are 3 enumerated choices: adaptive, fixed, and flexible. I actually think that adaptive is the one that you're going to use most times, so let's select this. Now, unlike fixed and flexible, where we specify the specific number of grid items we want to see in a row, with adaptive, SwiftUI will create the number of grid items that can fit across in a row. And it looks like this is requiring a minimum size, and since each of our rectangles has 100 points as its width, let's enter 100, if I could type properly. Whoa, and let's look at this. After I've got 100 in here, the adaptive view fits 3 grid items across on an iPhone 14 Pro, and we see 7 rows of those from top to bottom. Now our bluish cyan rectangles have a fixed width of 100. That should be unchanged, but the red that we see is our adaptive grid items increasing their size if the grid items can be expanded on the current device size. The white space that we see in between the grid items is a default spacing that's provided by GridItem. Cool. Let's build and run in the simulator and see what happens down in the console. We get 21 dangs, 0 through 20. Now we're still getting double dangs for each pass through the ForEach, but the point we're trying to make here is that we're very clearly lazily loading our grid items. We haven't loaded all 1,000 grid items at once, just what we wanted. We also see as we scroll up, the dangs indicate that we're creating new views as we scroll up. The numbers increase in sets of 3 for each row that's scrolled up. Lazy load, working properly with grid items. Now another nice thing about LazyGrids is if you change the orientation of the device, say tipping it on its side, then it'll reflow the grid items for the new dimensions of the device. And we can try this out in the simulator. Under the device menu, I'm going to select orientation and then portrait, landscape left. The other 2 menu items above this show that you can press the command left arrow or right arrow to rotate the device in those directions too. And we see the items spread out in the new landscape orientation, and we see while scrolling that we get 6 dangs per row instead of the previous 3. The print order might be a little bit different, but the print number, even though we get double dangs, is what we're expecting. Neat. After scrolling a bit, I'm going to command right arrow to switch back to the landscape orientation. By the way, it's also possible to see the orientation in the preview canvas, although I do note that sometimes Xcode is a bit buggy in the preview canvas and sometimes won't display things as completely as it will when it's run in the simulator or on a device, but let's try this out. At the bottom of the preview canvas, the third icon over from the far left, it looks like a 3x2 rectangle grid. If you hover your cursor over it, you'll see the tooltip says variants. Select orientation variants here, and cool! You can click on any given orientation, it'll zoom in, then you can click on the upper left back arrow, that'll zoom back out so you can see all of them. You can even try this with things like color variants, seeing light mode and dark mode side by side. Now we don't have any text in this particular app, so we wouldn't see any differences if we selected the dynamic type setting here. Now clicking the play button will reset you to live preview mode. We can also do this from the device settings icon over on the right. That's this icon that looks like 2 toggle switches. Select orientation. We can click on landscape, and this even allows us to scroll through in the live preview. Cool, but let's go back in device settings and turn off the landscape orientation so we see things in the portrait mode, which is the normal mode where we want to be using this app. And note that you can also go in the device settings menu and you can change the color scheme. You can also set different dynamic type sizes, and all of this will keep your preview so that it's live and it's interactive. Now back to our code, we also have control over the whitespace spacing that we see in between the grid items. There are a couple of places where we can change this. First, if we want to add whitespace in between the different columns of grid items, just after the close parenthesis of the minimum value, but before the second close parenthesis in the square bracket, enter the comma, so that's between the 2 parens, then start typing the word spacing. Code completion offers to enter this. Press return. We see code completion also puts the colon at the end. Cool. And let's put a 30 in here. And see how the blocks of the individual grid items spread out? We've just added a spacing of 30 points between the columns of the individual grid items. Now the spacing we added is so great that SwiftUI doesn't add any extra space around the grid item. That's why we only see the cyan, those blue colored rectangles that have a fixed size of 100. We don't see any additional red padding added as the adaptive format expands the grid items. Now if we decrease the spacing down to 0, we see that there's no white space in between the different columns, and the grid items are allowed to expand, so we see more red in here. When we add 1, we see a little thin gap. That's just a 1-point gap in between the columns of the grid items. And if you want to get rid of the spacing between the rows, you can add an additional spacing argument, but this one has got to go after the closing bracket. So this spacing argument is going to go inside of the LazyGrid, whereas the previous one was going inside of the grid item. So to add another argument to the LazyGrid, right after the square bracket, we enter a comma, then we can start to type the word spacing again. Code completion offers to fill this in, press return, we get the colon. If we put a 0 in here, we see this cuts out any of the spacing in between the individual rows. We've got no white space in between these rows of grid items. So you've got lots of control over how grids lay out, and this is just the adaptive grid item type. We can get additional control if we use the fixed and flexible grid item types, although with these options, we need to create an actual array to specify specifically how many columns we want to display in a row. Before we do this, let's go back to the default spacing. I'll delete the LazyGrid spacing parameter. We're going to delete the whole LazyGrid square bracket piece that we see after columns in just a bit. And then up top, we're going to create a new variable called columns that's going to create an array of grid items. So where we create our state variables, we'll say @state private var columns, lower camel case, equals, then I'll put an open and close square brackets, and in between those square brackets on 2 separate lines, I'll say grid item, I'll enter .fixed in here. Fixed wants to know how wide the column should be. I'm going to enter 100, so that should be a column that's just wide enough for the blue rectangles with no extra space, no red should show. And I'm going to create an array of 2 columns, so I'll put a comma after this, then on the next line, I'll enter the same line, grid item in between parens, .fixed in between parens 100. Then I'm going to highlight and copy this columns variable here. So this is an array of grid items. I'm going to delete the old square bracket columns value. I'd entered that as a literal directly in this LazyGrid statement, and I'll replace that pasting in columns, the value we just created. I've got to resume my pause preview, but will you look at that? I've got 2 columns, both of a fixed size of 100. Nice. You can scroll through this. You can also change the device type and see how this would look in landscape mode. You still get just 2 columns. That's what creating an array of columns that are not adaptive will do for you. Again, I think in many cases you'll want to use the adaptive type instead of creating an array of multiple columns, but if you needed to do that and create only 2 columns, this is how you do it. I'll switch back to portrait orientation. Now let's change the value that we're passing into fixed from 100 to 110. And there we see we get a little bit of padding inside of each grid item so we can see some of the red background. Now you can add a spacing value inside the individual grid items that are inside of your array of grid items in here. So here I've said comma, spacing :1. I get a 1 point space between the first grid item and the second grid item. You might look at this and say, well, what if I wanted to align things, say, to the left-hand side? Well, you can change this by adding an alignment parameter to the LazyVGrid. So after columns, I'll say comma, alignment, code completion shows it in here. Select this. I'm going to say dot, and look, leading is an option. We know that that means left justified. Press return, and our 2 columns are flush left. Change dot leading to dot trailing, and you see the columns are flush right. Nice. But I'll delete the alignment. I like centered, that's the default. Now if I copy and paste the second column, adding a third column down below, make sure you put a comma in between these. Now I have 3 columns. Notice that because I don't have a spacing parameter in the second column, I have the standard amount of spacing in between the second and third columns. I could change this by adding comma spacing :40 in that second grid item, and I get a whopping 40 points separating the second and third grid item. If I make it something very large, like 200, we can see that we start to push the columns off either side of the screen. That's another reason why adaptive columns are so nice. They reflow automatically depending on the size of the device and the space that's available. Why don't we delete the spacing? And if I decided that I wanted my middle column to be 150 points, I could just change my fixed value from 110 to 150. Column spreads out. My rectangle is always going to be 100 points, but I've got more extra space in here. That's why I see the red. I'll go back to 110. And now let me show you the flexible column type. I'll comment out these first 3 grid items here so that we can refer back to them to compare the two. And the flexible grid item is the default. So if below this I just type in grid item, open and close parens, I see what we started off with, where it looks like it's a LazyVStack instead of a LazyVGrid. We see each grid item expands flexibly to take up all of the space that's available. Since we have only 1 grid item in the columns array, that's why we're seeing only 1 column. Say comma, add another grid item, open and close parens. Now we see that we've got 2 columns in here. Flexible spacing will take up the available spacing to show those 2 columns. Add a third one with comma grid item. Now we got 3 columns. And now I'm going to comment these out and watch what happens when I uncomment the fixed grid items. We'll see a subtle change because the fixed grid items are fixed at 110 points each. Those grid items are slightly smaller than the flexible grid items that we're expanding to take up the available space. So I'll comment out the fixed items and head back to the flexible items. And let's use just 2 columns in here, and I'll also delete those commented out fixed items. We don't need those anymore. Now flexible is what we get by default, but we can go in between parens and type in dot flexible in here, and then we get parentheses, and we see if we type a dot in between those parentheses, I can enter a minimum value and a maximum value. So again, we get lots of flexibility in terms of how wide we would like these columns to be. If I enter max, it looks like it gave me minimum by default too, but we don't need that, so I'll delete that. I'll put maximum of 100 in here, and look what happens. Even though this is a flexible column, by saying we're going to take up a maximum space of 100, that's not really flexible at all. We've got a fixed size column in here, and we're not seeing any red space. But the other grid item below this can flexibly expand to take up all the remaining available space. Now what if I enter a crazy big number in here? So for my second column, I'll enter maximum :500, but because I can't expand to 500 and this is flexible, I just take up the available space, which is far less than 500 points. And you can play around with these values. So for example, I can set the first column to a maximum of 110. I see a little bit of red space. I'll decrease the maximum value of the second column to 200. Now we can see there's some remaining space to the left and right of these centered columns. Now, pretty much everything we learned with LazyVGrids also applies to LazyHGrids. If I look at code completion and check out LazyHGrid, the only noticeable difference that we have is there's a rows parameter instead of a columns one, but we can actually use the rows as columns as they perform the same thing just in a horizontal instead of a vertical orientation. So let's see this. We'll change LazyVGrid to LazyHGrid and the columns label to rows. Now, just as we learned earlier, we also need to update the scroll view for horizontal scrolling by adding parens after the scroll view and passing in .horizontal, but look at that. Our columns array of grid items functions perfectly as a rows array. It just formats with a horizontal rather than a vertical orientation. Ultra cool. So that's your fairly comprehensive intro to LazyStacks and LazyGrids. You've now got even more skills, Swifter, so now it's time for a challenge. So this shows the current state of the Dungeon Dice app after the last lesson. Buttons are arranged in a straight line. Not great, so the challenge is to modify the Dungeon Dice app that we built during our prior lessons with the appropriate lazy view, considering the ones that you just learned, so that the buttons cascade from the top left to the lower right. The number of buttons per row should change depending on the size and orientation of the device. Note you don't need a scroll view for this, since you don't have enough buttons to scroll. Also note, getting the remaining buttons to center is tougher than it looks, but we'll have a separate lesson to show how to do this, so for now, any remaining buttons can be aligned flush left, so pause, give this a shot. I know you can do it swifter. You can refer back to earlier parts in this video if you need to, and when you're ready, resume, and let's compare answers. So, Skilled One, hopefully you found this challenge astonishingly easy. To get buttons to cascade from top left to bottom right, we want to use a LazyVGrid with a columns value that's an array of only one grid item that's set to be an adaptive grid item. So let's build this bad boy. Above the ForEach, we'll add LazyVGrid, select the option with columns and content, then tab over to content for now, press return to get the trailing closure format we like so much, then we'll cut out the entire ForEach statement with its modifiers, paste it in between the curlies. This will perform that ForEach inside the LazyVGrid. Now we need to set up our columns, so I'm going to enter square brackets for the columns parameter. Since we want columns to change based on what's available, all we need is a single array of one element that's an adaptive grid item, so enter grid item in between parens. We'll say .adaptive. This requires a minimum value. And here I experimented. You could actually get away with pretty much anything in here since this is the minimum value and it will expand. Well, anything less than about 100 would look normal. But I was really curious what the minimum value for the button would be to fit all of the English language button text into a button on a single line. So I experimented. I put 100 in for the minimum value, but then I entered comma maximum to add the maximum value. When I enter 100 in here, this essentially makes the columns a fixed size of 100. But we see that's too small for the 100-sided option down here. See how a max width of 100 forces the button on two lines? Not a good look. But by experimenting, I eventually found that 102 was the smallest maximum value that kept everything in a single line. Again, you didn't need to do this, but that number 102 is going to be really useful for us in our next lesson when we try to center the buttons that are on the bottom line. So I'm going to change my minimum value to 102 and delete my maximum value. I don't need this. And that's it, Swifter. Once again, the big learning was anything but lazy. There are lots more skills to come, so stay tuned. Like and subscribe.